Alright, good day everyone. So welcome back to my YouTube channel, Kasaligan Vlogs. And today we will be talking about z-test for a mean. And we'll start first with the traditional method. So hypothesis testing, let's recall about the procedures in hypothesis testing. The first one is we need to state the hypothesis. So be sure to state both null and alternative hypothesis. Design the study. These steps include the selecting the correct statistical test, choosing a level of significance, and formulating a plan to carry out this study. The plan should all include information such as definition of the population, the way the sample will be selected, and the methods that will be used to collect the data. Third one is conduct the study and collect the data. And the fourth one is we need to evaluate the data. The data should be tabulated in this step and the statistical test should be conducted. Finally, decide whether to reject or not to reject the null hypothesis. And next is summarize the results. So here are the procedures. So first one is state a hypothesis and identify the claim. So first is hypothesis, and we need to identify the claim. Find the critical values from the appropriate table in Appendix A and compute the test value and make decision to reject or not to reject. So this table is in appendix of the Bluman book. Okay, make the decision to reject or not to reject the null hypothesis, then summarize the results. How to summarize the results? For example, this one, if the claim is our null hypothesis, when we reject the null hypothesis and our claim is the null hypothesis, the statement should start first that there is enough evidence to reject the claim. But if the claim is H1 or alternative hypothesis and we reject the null hypothesis, the statement should be there is enough evidence to support the claim. So take note of the word reject and support. When the claim is our H1, we have two statements should start with there's enough evidence to support the claim. But when our claim is H1 and it's being rejected, there is enough evidence to reject the claim. The next one is claim is HO. So the decision is do not reject HO. And our claim is HO, so we did not reject the HO. And when the claim is our HO, there is not enough evidence to reject the claim. So take note, the correct grammar should be there is not enough evidence. So you should not state there's no enough evidence. That is incorrect. So you start with there's not enough. Next is when the claim is H1 and you did not reject the HO. So there's not enough evidence to support the claim. So these are the statements that we need to understand and we need to comprehend about this. When to say reject and when to say support. Okay, z-test for a mean. So let's start first with traditional method by using critical values. So the z-test is a statistical test for the mean of population. It can be used either when, so there are two instances, n is greater than or equal to 30 or when the population is normally distributed and the standard deviation is known. And the formula for z-test is this one. Z is mean minus the mu over the standard deviation over the square root of n, where the mean, this is the sample mean, and mu is the hypothesis population mean, and the sigma is the population standard deviation, and n is the sample size. So assumption for z-test for the mean when standard deviation or the sigma is known. The sample is random sample, either n is greater than or equal to 30 or the population is normally distributed when n is lesser than 30. Okay, so take note either n is greater than or equal to 30 or the population is normally distributed when n is lesser than 30. So either of that condition. So next is problem number 1. In Pennsylvania, the average IQ score is 101.5. I took this one in a Blumen book. The variable is normally distributed and the population standard deviation is 15. So this is for educational purpose. So a school superintendent claims that the students in her school district have an IQ higher than the average of 101.5. She selects a random sample of 30 students and finds the mean of the test score is 106.4. That's the claim as 0.01. Let's start first with the step 1. State the hypothesis and identify the claim. Okay. Step 1. So in step 1, we have to state the hypothesis and identify the claim. So what are those hypotheses? First is the null and alternative hypothesis. So we had discussed in the first video all about introduction to hypothesis, how to state the null and alternative hypothesis. So now, if you have watched the video, we already know how to put this one in a symbolic form. So HO is mu is equal to, what is the mean? The mean is 101.5. And our H1, or alternative hypothesis, it stated that a superintendent claimed that students have higher IQ average of 101.5. So mean to say our mu is greater than 101.5. So which in this statement, this is our claim. Since stated that in her school district have a higher IQ higher than average of 101.5. So amo ni atong claim. Unsay claim mao na atong panaghap nga mao ni nga ang estudyante in her school district IQ higher than average of 101.5. So man atong gi-claim ba? Man atong nga mao dyan ni, para na mao ni siya. Okay, that's our claim. So step number 2, find the critical value. Since alpha, so what is our alpha here? This is our alpha, that rather, this is alpha. Alpha is equal to 0.05. So the test is, this one is a right-tailed test. Okay, right-tailed. The critical value. So since, how to get the right-tailed test? The right-tailed test, since the critical value is, okay, so the critical value, how to get the right-tailed test? 1 minus the alpha. So what is 1 minus the alpha? So 1 minus, which is alpha is minus 0.05, that is 0.95. Okay. Point 0.95. Okay, 0.95. So we have to select here. So this is the closest one, 0.950. So therefore, 0.5, that is 1.65. So the first is, in step number 2 in critical value, 1 minus the alpha is equal to 1 minus 0.05, that is equal to minus 0.05, that is equal to 0.9500. And this the closest one is the critical value. Our CV here is 1.65. Positive 1.65 because this is right tail test. So therefore, our Z value here is 1.65. That is positive 1.65. Third step. The third step is compute the test value. Since we are computing the z value here, so z is equal to mean minus the mu over the standard deviation times the square root of n. So compute this one. We have what is our test score? What is the mean of the test score? So we have here 106.4 minus 101.5. So over uh, standard deviation, which is 15 over the square root of how many? We have 30 students. So 30. So compute this one using a calculator. So we have 1.79. So 1.79. Next is we have to make a decision. So fourth step, we have to make a decision. Okay. In decision making, so we have to draw this one. Dali siya ma-check. Sorry for my figure. Okay. That is 0. This one is 0.005. And our z value is 1.65. And the test value is 1.79. Here, 1.79 our test value. So therefore, in this part, the test value falls in the rejection region. Okay, region. So the test value is in the rejection region, not in the non-critical region. Non-critical region. So this one, so therefore, we could say that we have to reject the null hypothesis. So therefore, this one is reject the null hypothesis. Okay, we have to reject the null hypothesis because since the test value is 1.79, which is greater than the value that is the critical value, which is 1.65, so therefore the decision is reject the null hypothesis. And the last one, so we have here, since the claim is the alternative and we reject the null hypothesis, let's go back here. The claim is the alternative and we reject the null hypothesis. So therefore, our statement in our summary should start with there is enough evidence to support the claim. Okay, so that is our statement. So in summary, so there is enough evidence to support the claim. And what is your claim? The claim is that the IQ of the students, the claim that the IQ of the students is higher than the state, okay, than the state average IQ. So let's say claim that a superintendent claims that the students in her school district have a IQ higher than the average of 1.05. So this is that is meaning to say that our claim is the IQ is higher than the average of 1.05. That is the state average IQ of Pennsylvania. And their students is higher. So therefore, we reject the null hypothesis. So there is enough evidence to support the claim that the IQ of the students is higher than the state average of state average IQ. So in this problem, we can say that the difference is said to be statistically significant. However, when the null hypothesis is rejected, there is always a chance of committing type 1 error. In this case, the probability of type 1 error is at most 0.05 because we are using the alpha, which is 0.05. So we could have that one that we could always have a chance of committing here a type 1 error. So what is a type 1 error? So, di ba? Natay type 1 and type 2 error. Okay. So, that was discussed in the previous video. So, let's proceed with problem number 2. So, for a specific year, the average score of the SAT math test was uh, was 515. The variable is normally distributed and the population standard deviation is 100. So first the I, we are going to start our write our given. So our given here is a standard deviation is 100. Okay, what is the given? Uh, the same superintendent is superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selected 36 student scores. So our N is 36. At alpha, this is alpha, alpha, at alpha 0.10. Is there enough evidence to support the claim? So, what is our claim now here? So, the first step is we need to identify the hypothesis and identify the claim. So, our HO here, mu is equal to 515. And there's no difference in the average of the math test was 505. And our H1 here is mu is lesser than 515. So significantly below the national average. So this is our claim because this is given in the problem that we see if our student scored significantly below the national average on the test. The next one is we have to find the critical value. How to find the critical value with the alpha 0.10. If the critical value is alpha 0.10, okay, just locate it in the table. If we're going to locate in the table, this is not the positive, negative. So if we're going to locate in the table, so before, so we have here a critical value is negative 1.28. So imagine that this is a critical value which is our z value is negative 1.28. The z critical value, CV. The z critical value is negative 1.28. The next step is we need to compute the test value. Since mean is not given, so we need to compute the mean. So we have to add all of the scores. So in the previous video, I uh, I taught you on the how to compute the mean using your calculator. So therefore, just add all this one and divide it by the number, which is uh, our end here is 36. So 36 student scores. So now using our calculator, the mean is we have to add 496, 555, 522, 519, and so on, divided by 36. The result of this one is 509.028. So that is our mean. So now we could now compute what is our z value. So the mean minus the mu over the standard deviation square root of n, we have 509.028 minus 515 over 100, which is the standard deviation over the square root of 36. So by the use of your calculator, we could compute that the test value is negative 0.36. Okay, negative 0.36 as our test value. The next step is we have to, we have to find, we have to make a decision. So fourth step, we have to draw a standard distribution. This one, a graph here, and since our z critical value is negative 1.28, and the result of our test value is just negative 0.36 here. So this is the critical region, and this one is the non-critical region. So non-critical region. So therefore, the test value falls in a non-critical region. So the decision is not to reject the null hypothesis. Why? Because it falls in the non-critical region. This is our critical region, and this is non-critical region. So now, if the claim, we have to summarize the result. If here, go back here in the first statement, if the claim is our H1 and we do not reject, the statement should start with, there's not enough evidence to support the claim. Okay. The summary is there is not enough to support the claim that the students scored below the national average. Okay, so that's it for this one. So it means that the sample mean of 509.028 is lower than the hypothesized population mean of 515 here, and it is not significantly lower. So based in here, it is not significantly lower. So hence the difference may be due to chance. When the null hypothesis is not rejected, there is a probability of committing type 2 error, of not rejecting the null hypothesis when it is false. The probability of type 2 error is not easily ascertained. Okay, so it is only to realize that the probability of type 2 error exists when the decision is not to reject the null hypothesis. If we're going not to reject the null hypothesis, so therefore we are probably there is a probability of committing type 2 error. Okay, let's proceed with problem number 3. In problem number 3, the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,000 $24,672. To see if the average cost of rehabilitation is different at particular hospital, a researcher selects random of samples 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is 26,343. The standard deviation of the population is 3,251. At alpha, this is alpha, at alpha 0.01, can it be concluded that the average cost of the stroke rehabilitation of a particular hospital is different from $24,672? So the statement here, first is we need to find the hypothesis and alternative hypothesis. So our HO here is mu is equal to $24,672, and our H1 here is mu is equal to, it's not equal because the statement is different from, so this is a common phrase that I've taught you all about the common phrase in the first video. So 24,672, which is our, this one is our claim. And we have here number 2, find the critical value. The test is two-tailed. The critical value is, so first is we have to find the critical value. So our alpha divided by 2, which is 0.01 divided by 2. So our alpha is 0.01 divided by 2. 0.01 divided 2, that is equal to 0.0005. 0.005 equal to 0.005. So the closer value to this one, let's start first with the left tail. So the left tail is, we have here the left portion is here. Closer to this one is between 0.51 and 49. So money atong gisolve last time nga between siya sa 7 or 8. So therefore, we have to move it to 2 point, that is negative 2.58. Because the result of this one is 2.575, negative 2.575. Since we're using two decimal places at this instance, so negative 2.58. So next is we need to have our critical value is positive and negative 2.58. This is for the right and the left. And number 3, we have to compute the test value. So Z, what is the given here? Our given is, the mean is, what is the mean now? Here is 26,340. Our population mean, our parameter is 24,672. Our standard deviation is, we have $3. This is $3251, and our n is 35. Okay, 35. So computing the Z, so you have here 26,343 minus 24,672 over 3251 square root of 35. So we have here 3.04. By using calculator, we have 3.04. And step number 4, we have to make a decision. So by graphing here, this is negative 2.58, this is negative, and this is positive 2.58. That is our Z critical value. So this is our critical regions. So it falls it particular here. Okay, nasa nadapit ani, so 3.04. So therefore, we could say that we have to reject the HO. Reject the null hypothesis since it falls in the critical region, which is beyond 2.58. Okay, that's our decision. Next step is number 5. Summary. Step number 5. Since H1 is our claim and reject the null hypothesis to start with, there is enough evidence to support the claim that the average cost of rehabilitation at the particular hospital is different from $24,672. So that is the fifth step rather. So here's problem number 3. So try this at home. So you have 1 to 3 questions. So you have to submit it one during our meeting and make sure to submit before our to start with our meeting. So God bless everyone and see you in the class.